Okay, we are group 32 and we are going to report our second challenge, advanced regression techniques. Okay, so we have 6 topics. First is the housing dataset. Second is the data preprocessing. Third is the math evaluation. Fourth is sklearn. Fifth is the XGBoost. And the final 6 is the evaluation. Okay, first, the housing dataset. It has 79 variables, or as known as features, and we have to pick some useful features from all these variables to train our models. Our target is to guess the sale price of the house, and via the model we trained.
Moving on to data preprocessing, the very first step, step 0, is the data exploration. Let's take a look at the data set. And using train.describe function, you can see the different count, mean, standard deviation, minimum, and maximum of the different classes and features. Next, we encode the data. String categorical data are encoded into numerical values in both training and testing dataset so that in the later part of running our models, we could successfully run our models with all numerical data. Next, handling of missing data. There are missing values that we have to handle for both training and dataset. For the training dataset, we drop the missing values, and for the testing dataset, we fill the testing missing values with 0 so that we could keep all data available for the testing dataset. Furthermore, we drop the ID column of the dataset as it is irrelevant to our context. Next, we did feature transformation to skew the data using standardization. As we can see from step 0, the maximum and minimum of the different features are great. Hence, we have to standardize the whole dataset so that we can have an unbiased model in our running out of models. Next, we did feature selection. As there are 81 columns, 81 features in our dataset, it's too much for visualization, and we would like to simplify the dataset. Hence, principal component analysis (PCA) was used to filter out the features that contain most of the information while simplifying our model. Next, we split the dataset using train test split function into training and validation dataset. The validation set was used to test the performance of the model before feeding it into the testing dataset. Last but not least, we remove outliers that are far away from the majority of the data points. And on the right, we can see the before and after of the removal of data of outliers. From the figure, we can see that we managed to condense most of the information into relevant points. Moving on, we'll look at the matrix that we use for evaluation.
So now I'm going to introduce the mathematics calculate method about our module that we use to check whether our module is well predicting or worse predicting. So first is the mean square error. It is used to measure the prediction of our accuracy of the model. So the lower value we get, the better our model will be. And the mathematical formula is that we'll have to first get the subtract the difference about the actual and prediction price, then squares it and sigma O of them. After that, we'll have to get the average of it, and they'll become our mean square error. Next comes to the root mean square error. So compared to the mean square error, root mean square error, we just have to get the square root of the mean square error after we calculate the mean square error. So the lower the value of RSM the better our model will be, such as the same as the mean square error. Last is R squared. So R squared is to calculate the correlation about our predict price and actual price. So the higher relative we get of both of them, the higher R squared we get. So the difference was due to of the formula that I introduced previously. The higher R squared means that the better our model is able to predict the values.
Okay, and next is the regression part, which is divided into four types: linear, lasso, ridge, and net elastic. Then we will briefly introduce their principles. That is in linear regression. Linear regression is a statistical method used to establish a linear relation between input variables and output variables. It makes predictions by fitting a linear equation to minimize the square error between actual observations and the model predicted values. And next up, lasso regression. Lasso regression is a variant of linear regression that uses L1 regression to constrain model complexity. And L1 regression promotes sparsity in the model by adding an absolute value penalty, which tends to set the coefficient of some feature to zero for future selection. And next part is ridge regression. And ridge regression is also a brand of linear regression that uses L2 regression to constrain the complexity of the model, and L2 regularization reduces the coefficient of feature by adding a square penalty but does not set them to zero. It helps reduce collinearity between features. And next part is elastic net. Elastic network is a combination of lasso regression and ridge regression, with both L1 and L2 regularization applied. Elastic network combines the advantage of two kinds of regularization, which can perform feature selection and handle multiple linear groups. But by adjusting the missing parameters, the weight of L1 and L2 regularization can be controlled to meet the needs of different problems. And next part.
Okay, so now we are going to introduce the XGBoost model. So the first thing is that to train an XGBoost model, you should import some libraries. So you need to import the XGBoost library to create and train your model, and as well as our common data science library like pandas and sklearn for data manipulation and processing. And next is data splitting. Because our data is continuous, so we have to split our trained data into test and train. And this equal to y test. And this part is in the pre-processing data, so we can skip it. And next, we can the next part is model initialization. So to create an XGBoost regression model, you can set a hyperparameter like an estimator. This means the number of boosting rounds and learning rate, max steps, and other based on your problem and data sets. And our and estimators is 2000, the new rate is 0.01, and max dips is 3, and random state is 123. So next is model training. So feed the XGBoost model to train our training data. So next is to model evaluation.
So to evaluate our model on the data and our test data, for regression tests, you can use mean square error, MSE as common evaluation metric.
Okay, the final. This is our final evaluation of our model with mean error square 30,000, rule mean square error 175, and correlation 0.83. Thank you.